Hello, and welcome to my video on the January 2019 Algebra 2 Regions, question number 37. In this problem, we have that Tony is evaluating his retirement savings. He currently has $318,000 in his account, which earns an interest rate of 7% compounded annually. He wants to determine how much he will have in the account in the future, even if he makes no additional contributions to the account. Write a function a of t to represent the amount of money that will be in his account in t years. Then after that, we have to graph a of t, where 0 is less than or equal to t is less than or equal to 20 on the axes below. So this being a part 4 problem, there are several parts to it. The first of which, again, is to write a function a of t to represent the amount of money he has in his account. And because of the terminology that in this account he's going to earn an interest rate of 7% compounded annually, and the compounding is a set time period, I'm going to refer to the formula that we dealt with this year of P 1 plus R over N to the NT. And if we use this formula and start plugging in values that we have in our problem into this equation, remember that P stands for the principal, and the principal is the initial amount that is invested in the account. In this problem, that would be the $318,000. And then the 1 plus the R is the interest rate, which in this problem is the 7%, but we do need to convert that into a decimal. So 7% would be equivalent to 0.07. And remember, that's the number of compounding periods during the year. Since the interest is compounded annually, annual means just once a year, so n would be just simply 1. And then we would have this all raised to the 1 times t. And this would be our equation, but we could, for the purposes of this problem, simplify it down and write this as 318,000, and then the 1 plus the 0.07 over 1, we can simplify that to just being equal to 1.07, and 1 times t is just t. And this here would be the first part of this question. This would be our equation. And then next, they asked us to graph this particular equation. And in particular, to help graph this equation, we can go to our graphing calculator. And remember that when they give us this grid here, we have to make sure that we place our entire graph on this grid. We can't extend it. If you do extend the grid here to try to fit your graph on here, you will lose credit. So if we go to our calculator now to help with getting this graph down on paper, right, I would say put our equation into our calculator first, and then if we perhaps just graph this on a normal viewing window, we're not going to see anything at all, and that is common with these types of problems. So to help see things, we can go to our table and start to get a sense of what our y values are. And star net x equals to 0 and all the way up to 20, we see that we're starting off at 318,000, and our values are going to steadily increase. The one thing to note here, and this is typical anytime you're working with your calculator, is that the last two values have the letter E in here. And anytime you see this E on your calculator, that stands for scientific notation. So this value here represents 1.07 times 10 to the 6th power, which 10 to the 6th power is 1 million. So technically this value here is 1,070,000. And this next value would be 1,230,000. So these values here are what we could use to help plot out our graph. And you'll notice that while we have to go from 0 to 20, I've gone by 2's here to help with actually plotting out our graph. So now if we go back to our provided grid, along the t-axis here, I would go by, or each value, each increment here, I'm going to go by 1, and I'm just going to label every second value. So that will help with plotting out my points. And now along the y-axis, there are 20 increments there, but remember, I can't go above this highest value here. I have to make sure that I scale my y-axis accordingly so that I can get all my points on here. And there's not necessarily just one correct way to do it, but since I have to obviously get 318,000 down there, as well as get up to all the way up to 1,230,000, I'm going to scale my axes by each increment going by 100,000. So if I do that, that would mean that this fifth value here would be 500,000. And then 1, 2, 3, 4, 5. This value here would be 1 million. And labeling these as such would identify the fact that I'm scaling my x-axis by, my y-axis by 100,000. So now with my y-axis scaled and my x-axis scaled, again, I can take each of these values and plot each point down to help draw up my graph. So I'll do that now. So we have at 0, we have a value of 318,000. At 2, we're at 364,000. At 4, we're at 416,000. At 5, at 6, we're at 477,000. At 8, we're at 546,000. At 10, we're at 625,000. At 12, we're at 716,000. At 14, we're at 800 and basically 20,000. At 16, we're at 939,000. And at 18, we are just above 1 million. And at 20, we're at 1,230,000. All right, and with those points plotted, we can do our best. And I'm going to apologize right now. We can do our best just to draw out our graph through those given points. And now remember, when you do this on your regions, when you draw out your graph, you are allowed to use a pencil, and I would highly recommend you do so, so that if you, like I did here, kind of make some little mistakes or whatnot, or if it's not 100% accurate, you can erase and then draw your graph accordingly. But scaling the axes is crucial, and then drawing out your graph accordingly, you should receive full credit for the graph portion of this problem. So now that we have the graph down, the next and additional things that we have to do here, it says that Tony's goal is to save 1 million, determine algebraically to the nearest year how many years it will take for him to achieve his goal. And then after that, explain how our graph confirms our answer. So for Tony to reach his goal of 1 million, what we can do algebraically to solve for when this would occur is we can take our equation, we could plug 1 million in for A, and then solve for T using our equation. So if we do that, again, we would set 1 million equal to 318,000 times 1.07 to the T. And now, as was the case this year, when we're trying to solve for the variable which is in the exponent, we have to get the base and the exponent by itself. So we would start that process of doing that by dividing both sides by 318,000. And now when we do the division on the left-hand side, we can do that in your calculator. We would get in a simplified rational expression as 500 over 159, and that would equal the 1.07 to the exponent of t. And then now that we have the base and the exponent by itself, what we typically did was we now just take the natural log of both sides and we do this in particular because on the right hand side, because we've taken the natural log of 1.07 to the t, we are now allowed to bring that exponent of t down in front. So we'll have t natural log of 1.07, and this would still equal the natural log of the 500 over 159. And then the last thing that we would need to do to solve for t is to divide both sides by the natural log of 1.07. And that left-hand side, we can input all that into our calculator at once, and to the nearest year, we would get an answer of 17. And that's how long it would take for Tony for his savings account to reach $1 million. It would take 17 years. And now the last part of this problem, again, this is a part 4 problem, there's a lot here, explain how our graph of A of t confirms our answer. Well, his account reached $1 million after 17 years. And when we look at our graph, at 17 years here, at time of 17, we'll notice that our graph is right at $1 million, the amount that Tony wants as his account. So to explain how our graph confirms our answer, I'll write on our graph at t equals 17, the y value is at 1 million. And that should suffice as support for our answer to why our graph confirms our answer. And so this is a part 4 question. Again, it's typical that there are several parts to the problem. We had to write our equation. We had to properly draw out our graph. We had to solve algebraically for the variable t, and then write an explanation that ties together the algebraic solution to our graph. So it's a lot here, but I hope that this video in particular answered any questions on this problem. As always, good luck with all your studies, and thank you for watching. Take care.